Seems to be that almost every star has a planetary system, and the definition of habitable zone has expanded. It used to be that only Mars and Earth were potentially habitable. Now we've got an ocean on Europa.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Oh, yep, baby, this way.
Oh, yeah, baby ocean. Matt, that was Frank Drake, of course. And it's a beautiful quote. And I genuinely don't think I've been as excited about a podcast as I am today. And that's, you know, even including the Rings of Saturn, which you know how excited I was then.
Yeah, Rings of Saturn. One of the things we're going to be talking about causes one of the Rings of Saturn.
You know what's more exciting than Enceladus? And that's my new favourite thing ever in the solar system, Europa.
More on that later, because we're going to do a little bit side-by-side comparison of the icy, watery moons of the solar system.
Hold on to your hats. Put something waterproof on.
Oh.
That was very creepy.
Yeah, it was a bit. November the 23rd is the 327th day of the year, Jamie, and it's also the birthday of hapless Vladislav Nikolaevich Volkov.
Big Vlad.
Who, of course, was a cosmonaut born in 1935 on this very day, and he flew in Soyuz 7 and Soyuz 11 missions. Yes, and Soyuz 7, Soyuz 7 was supposed to dock with Soyuz 8, with Soyuz 6 filming, but it didn't happen, and that's often considered one of the sort of biggest nails in Russia's lunar program.
Oh.
And then, and a little interesting side note is the Buran was the name of that Soyuz 7 spacecraft. It means blizzard in Russian, but of course it was later reused for their shuttle space.
Well, check that out.
Yeah. Soyuz 11, however, is, of course, one of the worst disasters in space history.
It wasn't good.
Poor old Vlad and his two other crew members are the only people to have died in space.
Yeah, it ended badly, Matt, when the crew capsule depressurized during preparations for re-entry, killing the 3-man crew.
Yeah. Oof. But in his honour, there's a crater on the moon called the Volkov.
There is.
There's a tomato called the Volkov. And
is there?
That was bred in memory of him by his gardener friend, Nikolaevich Maslov.
Oh.
There's another birthday, Jamie. Another birthday happened this week.
Another one? Who's it?
Pretty monumental. It's the 20th birthday of the ISS.
Oh. Happy birthday, our lovely little space station.
Weird to think that the ISS has been around for a fifth of the time that women have been allowed to vote in this country.
Yeah, that's mad.
It's weird, isn't it? The Zarya module was launched on 20th of November 1998 on a Proton.
Beautiful.
And that's the start of the International Space Station.
Well, that's where it all began. It provided propulsion, attitude control.
You need attitude control.
Oh, I do actually, don't I? Communications, electrical power. But, Matt, it lacked long-term life support functions.
So up went the Unity module a couple of weeks later on the space shuttle, STS-88 to be precise.
Uh-huh.
And that was installed by the astronauts doing EVAs. It was only supposed to be autonomous for 6 to 8 months, but it ended up being autonomous for about 2 years while the Russians got the Zvezda module ready.
True.
And that finally got launched on 12th of July 2000. And on 26th of July was docked. And currently, of course, the ISS has a 3-man crew.
It does.
And you know what? I was in Ilfracombe, I was at the centenary celebrations, and they had this 1 minute silence. But as I had this 1 minute silence outside, and they were projecting all this stuff onto the theatre there, on the outside of the theatre, it was amazing. There was a satellite that flew over, and I was thinking, wouldn't that be great in the 1 minute silence if we had a satellite flyby of a Russian, a German, and an American flying overhead during the 100th celebration of Armistice. I thought that was quite appropriate.
That is absolutely beautiful thought, isn't it, really? Just kind of how far we've come.
Sort of. I mean, it would be better if we were getting on better with the Russians at the moment, wouldn't it?
Well, yeah, it's very true. It's not the best time, but at least we can get stuff done in space, you know?
Talking about getting stuff done in space, there's one thing that we should talk about at some point on another show, and that's Space IL and their plan to get a spacecraft on the moon next year, which is pretty phenomenal, isn't it?
This is exciting, isn't it? I mean, they really do have a lot of ambition.
Yeah, and recently they've just had a boost of $5 million from Sylvan Adams, who's an Israeli-Canadian real estate billionaire. So he's been putting the support in. His previous support has gone to things like velodromes because he's a bit of a cycling nut.
Wow.
Really good news for the British space launch, particularly down at Newquay.
Virgin Orbit.
Our Cosmic Girl has flown with a Launcher One air launch system actually captive on the flight, so hanging underneath like a missile. And the pilot was very happy. He said, "The vehicle flew like a dream today. Everyone on the flight and all of our colleagues on the ground are extremely happy with the data we saw from the instruments on board the aircraft."
That is ace news. And the picture looked incredible as well. If you haven't seen it, check it out.
And Brano has been saying that, there's going to be multiple trips to orbit in the year ahead. And they expect the first one to be early next year. So that could be very exciting. And possibly one from the UK. That'd be insane.
We will be the first in line.
So here's a terrifying one for next week. Is Mars Insight.
What's happened?
Well, so it's the terrifying moments of terror for Insight to go through on its landing at the Red Planet. Do you know two-thirds of Mars landers fail? Just to put that into perspective.
It's not the easiest thing, is it?
So it's Insight went up six months ago. I can't believe it was that long ago. And on a 300 million mile trip.
Love that.
And its engines are slowing it down now. Then on 11:40 a.m. on November the 26th, it will separate from the cruise stage, then start its atmospheric entry, going 12,300 miles an hour. It's got to burn off all that speed. And it burns it off in the atmosphere. The heating of the protective heat shield gets to about 1,500 degrees centigrade. And it will slow down. In about 15 seconds, it will start it will get to its peak deceleration. Then the parachutes deploy. Then the heat shield comes off. Then the lander legs come out. Then the radar comes on and starts looking for the ground and acquiring the signal of the ground. Then its back shell flyers off, another parachute, retro rockets, and then it does a gravity turn so the lander's in the right position. And then it slows down using constant velocity to get to a soft landing and is expected to touch down on the surface of Mars at 11:54 a.m.
It all happens very quickly, doesn't it?
Yeah, 11:54 a.m. And that's from 11:40 from separating from the cruise stage. So yeah, it's all minutes. And then
fingers will be very much crossed.
Then hopefully at 12:04 we should receive the first image from Insight from the surface of Mars. I mean, that would be incredible. And hopefully at a similar sort of time we'll know that the solar arrays have deployed. So that's a big risky one. That's going to be pretty intense.
Well, best of luck, Insight. We will be thinking about you. Please let this happen. Yeah?
Yes. I can't wait. That's going to be a very exciting next week, that one.
That is going to be ace.
But we should talk about SpaceX.
Drink.
Old Elon Musk. But there was a very interesting article in Business Insider where a NASA associate administrator, Stephen Yurzik, has admitted that he says, I think our view is that if those commercial capabilities come online, we will eventually retire the government system and just move to buying launch capacity on those rockets. So essentially he's saying if BFR and New Glenn come online, the SLS will be retired.
Oh.
That's pretty big.
That is big news. And Matt, didn't I read that he wants to call the BFR Starship from now on?
He wants to call it Starship, despite the fact that it's clearly not capable of getting to another star.
Yeah, well, it's ambitious like all of his plans.
Unless he means our star, that he can travel around the solar system.
Yeah, that's true.
Maybe I'm going to give him that.
Let's give him that.
Yeah, not only that, he's been talking about sort of having a miniature version of it, like a little small test one that flies on the normal Falcon 9.
Oh.
Like a little tiny version of the spaceship.
Little mini-me.
Little mini-me, and they're no longer planning to upgrade Falcon 9 second stage for reusability. So that means that all their attention is going into BFR and this little spaceship, and then obviously the full-size one. And Eric Berger, I thought, kind of summed this up the best. He said, Musk is still trying to find the sweet spot between performance cost, effectiveness, and a product he can sell to customers, investors, and the government. That's true, because the design is apparently changed quite radically. He's actually said, Musk had it, accelerating BFR instead. New design is very exciting, delightfully counterintuitive. A radical change. So the next time we see a design of BFR, it's going to be different yet again.
Matt, you can't rely on much in this podcast, but what we can rely on is a quote from Eric Berger. Just great again.
Awesome. And NASA have picked a landing site, talking of landing on Mars and the stress. Mars 2020 rover, which will only be a year and a half away now, they're going to land it at Jezero crater, which was once a water-rich area billions of years ago on Mars, and so still might hide signs of alien life.
Ooh. Dun, dun, dun.
So it's a 45-kilometre wide crater that once held a lake and now holds a spectacular ancient river delta.
Well, it all makes the mind boggle, Matthew.
Mm-hmm. So do you want to get onto our feature, Jamie?
Yeah, I'm itching to.
Space feature of the week.
Here we go. Water moons in our solar system.
Yeah, we're doing this because this was suggested by one of our listeners that they wanted to hear a little bit more about the old icy moons, watery moons. That's no moon.
Well, Matt, I mean, it always fascinated me. We've touched on it before, the moons of Saturn and, of course, Jupiter. But it was only when I really started to go deep dive into researching it that I got very excited. Matt, where do we start?
I'm going to start with my favourite, Enceladus.
Oh, hit me.
You know what the word Enceladus means?
It was always named after one of Zeus's lovers, wasn't it, Matt?
No, those are the Jupiter ones, those ones.
Oh, so what's this one then?
It is Greek, but it's the offspring of Gaia and Uranus, Earth and Sky.
That's Earth and Sky, yes, okay.
Yeah, it's a giant. Enceladus was a giant. Discovered by the German-British astronomer Friedrich William Herschel.
Good work, Herschel.
In 1789. I mean, how awesome is this? It's the first use of his new telescope, his 47-inch telescope. You got to imagine how excited you'd be if the first thing you do is discover a moon.
That's just be mad, wouldn't it? So cool.
One of the ways that he was able to see it is because it was the Saturnian equinox, which means that the ring plane isn't sort of side on. It's absolutely in our line of sight, so it appears as a very thin line. And so it's not so bright that it bleaches out the moons. It doesn't. The moons aren't lost in the glare of the rings. So it's like a really good time to see those moons when the rings are straight on. And it's the 6th largest moon of Saturn. And of course, its main feature is it's covered in fresh, clean ice that's heavily cratered.
Very smooth and white, isn't it, Matt?
Yeah, very white, very smooth, very young. But really interestingly, it has tectonically deformed terrains.
Kind of sounds like a description of me, actually.
Yeah, imagine like 1789, all it ever was a pinprick of light until Voyager 1 and Voyager 2 set off in the 1980s and revealed these youthful terrains, which was a massive surprise to absolutely everyone. It was like, whoa.
Absolutely was. It's like, oh, we're seeing all this other stuff. Didn't they discover, how many moons did they discover?
I don't know. How many moons?
Got a feeling that Voyager discovered 5 extra moons.
No way.
But I'm pretty sure that that's the case. But anyway, carry on.
Yeah, so 2005, of course, is the big one when Cassini started doing multiple flybys of Enceladus. And that's revealing much, much more detail. And of course, the very exciting thing is the water-rich plumes venting from the South Polar region.
Imagine, because first of all, apparently when the photo came back, they were really excited and they said, is this the camera exposure? And then when they went back again, they saw from its South Pole, all of these plumes. And I mean, wow! Imagine the excitement knowing that water vapor.
Didn't they think it was a moon as well, sort of peeking out from behind the Enceladus?
Yeah, I think you're right.
And and it's just like totally incredible. But these cryovolcanoes, as they're called, there's hundreds of them, and they spew out water vapor, hydrogen, sodium chloride crystals, ice particles at 12 tons a minute.
So, Matt, when you said sodium chloride crystals, so that's kind of salt water. So remnant of Earth, it would probably mean that it's in contact with some kind of rocky substance.
Mm-hmm.
That's really exciting.
Yeah, so it's looking more and more likely that that it has the hydrothermal vents on Enceladus.
Well, that's the building blocks of life on our planet.
Exactly. It's very, 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 very exciting. Where does all the energy come from, though? It's like it's way, way, way out. And as the Frank Drake quote we used right at the beginning said, it's like there was a habitable zone, and it's like where you can have liquid water. But really, that should be expanded because we're finding, even in our own solar system, that liquid water doesn't have to exist just because of the heat from the sun. So this heat is generated by an orbital resonance that Enceladus has with Dione. So because they're on this 2-to-1 ratio as it goes round Saturn, it's getting pulled and pushed. So Enceladus is very, very round actually, but it's getting pulled and pushed by Dione as it goes round, and it's those tidal forces that are heating up the interior.
It was Neil deGrasse Tyson that explained it like when you're in a squash court and you want to warm up the ball. When you're hitting it, it squashes it and energy goes into the ball, making it actually warm, like when you're rubbing your hands together. So if there's rocks and plates underneath, all sort of twisting and turning underneath this water vapor, I mean, that is the energy that could be created, Matt, that might mean that there could be life there.
There's an energy gradient for life to feed on, an entropy gradient even for life to attach itself to and become part of.
Very exciting.
The plumes from Enceladus, as we said on the Saturn's Ring program, are that actually creates Saturn's E-ring, or most of the material in Saturn's E-ring, which is a vast, vast ring on the outside. And if you remember my little song, you'll know which number ring it is, of course. But what's interesting is Europa is only about the size of England. So you could wrap the British Isles around it. So it's quite small. It's actually quite small. But it seems to be that it's only about 100 million years old. So that might be a bad thing towards like it's the idea that there might be life on there,
Right.
But or not. I mean, it's not certainly enough time for life to develop, but it's very young.
It is young in the grand scheme of things. But Matt, who knows?
Yeah, there's a salty ocean, and it seems that there's like movement in the ocean, which is very important. That it's washing along maybe these hydrothermal vents. So in 2017. NASA announced that they thought that they'd found these hydrothermal vents. So all the recent science has been pointing towards that this is a very exciting place to visit. So have you any idea of the sort of things that they're building to go and visit Enceladus?
I don't know. Tell me.
So originally ESA were looking at a thing called Tandem, which was a system that was going to look at Titan and Enceladus. So Titan, of course, is extremely exciting as well because there's liquid on the surface, even though it's liquid methane, but it has lakes and rivers and things. But Enceladus, for me, I think is a better candidate for life. But ESA was going to build, in 2007, was looking at this Tandem. Then that kind of became the TSSM, which was ESA's Tandem mission and NASA's Titan Explorer kind of merged together. It's kind of on hold, but I think it's probably I think they've knocked it on the head. But it could still be on hold. There's a chance that they might resurrect that program and launch it on an SLS.
Okay.
That's what it was supposed to go up on anyway.
Well, they better hurry up then. Yeah.
Then there was JET, the Journey to Enceladus and Titan, which JPL proposed. But that lost out to Lucy, and we did an episode when Lucy won that particular Discovery Program bid.
That's right.
The German Space Agency, the DLR, have the Enceladus Explorer, which has a little ice mole, which is basically a very hot probe that melts its way through the ice and explores that way. And that's run by a research consortium of 7 German universities. So that's still on the table.
Isn't that also the one that has mercury to make sure that it doesn't get unbalanced?
Oh, I don't know. Have you been looking at that one then?
Yeah.
Nice. Then you've got Life Investigation for Enceladus, and the acronym is LIFE.
I see what they've done there.
Yeah. And that wasn't selected for phase A of a Discovery program, so that's kind of the end of that. Then there's ELF, which is Enceladus Life Finder, which
like it.
Yeah, we're not going to go with Life. We're going to go with ELF, and that's going to fly around and look for biosignatures and biomolecules in the geysers of Enceladus. And NASA and ESA have put together an explorer called the E²T. This is a 2017
It's a way
proposal.
more geeky one.
And that, again, is going to orbit around Enceladus and Titan, measuring both moons with high-resolution mapping and radio science and stuff to try and figure out what's going on.
Mm.
And also the Enceladus Life Signatures and Habitability, ELSA, is probably another plume sampling mission. But it lost out to Dragonfly and Caesar. And Caesar is going to 67p.
Bargain.
Churyumov, Cherisamenko. See? That song definitely works because I can always remember the name.
It's a hit single.
It is, massively. Dragonfly is going to Titan. But there's could be a chance that one gets another rebirth of life. And can reapply for New Frontiers.
Do you know what else is going to tighten, Matt?
Oh, what? So Jamie, tell me a little bit about Europa.
Oh, I'm so excited. Here we go. Let's do a deep dive.
But where does Europa get her name from?
Well, Matt, it's the legendary mother of King Minos of Crete and lover of Zeus. That's where I was getting mixed up.
Aren't you a lover of Zeus, the band?
Well, yeah, I mean, Zeus the band, legendary. But yeah, he did have a lot of lovers, didn't he, old Zeus?
You're not going to run out of lovers for moons.
He was quite a cad.
How ace a name for an album is that? Lovers for Moons.
It's pretty prog rock.
Yeah, that's brilliant. Nice.
But yeah, so the smallest of the 4 Galilean moons orbiting Jupiter, Europa's coated by twice as much liquid water as sloshing around on our planet, Matt. They reckon that it might be up to 10 times as deep as our ocean.
Oh, okay. So 10 times as deep as the deepest bit.
So 2 to 3 times as much, and 10 times possibly as the deepest part of our oceans.
Wow.
Which is pretty deep. So yeah, discovered by Galileo on the 8th of January 1610, and possibly independently by Simon Marius.
Yeah. So I think it's another German.
Yeah, it would be, wouldn't it? Mm-hmm. So Pioneer 10 and 11 in 1973-74 took tantalising images. Then Voyager probes in 79. And most importantly, Matt, the Galileo probe. New Horizons took a picture as it whizzed past on its way to the Kuiper Belt and to Pluto. And this is super exciting, Matt. I mean, excitement among the scientists as they were looking at the cracks in the ice on the top. They realised that the shifting of the cracks and the refreezing of the cracks meant that there was almost definitely an ocean water underneath. And just like Enceladus, this potential for hydrothermal vents. And do you know the word abiogenesis, Matt?
No, hit me.
Do you know what that means?
No, hit me with abiogenesis. It means
life thriving off hydrothermal vents, sulfur and hot temperatures. The natural process of life arriving from non-living matter, such as simple organic compounds. That's abiogenesis.
Probably more feasible than panspermia.
I reckon you're right.
Yeah.
So, yeah, it's slightly smaller than Earth's moon, primarily made of silicate rock and has a water ice crust, as I just explained. 6th largest moon and 15th largest object in the solar system.
15th
because
largest?
Obviously we all know how massive Jupiter is. And this is just a testament to that one of its moons is the 15th largest object in the solar system.
Even then, it's only the 6th largest moon.
Yeah, which is nuts, isn't it?
But it's a lot bigger, isn't it, than Enceladus, Europa? It's huge.
It really is. It really is. So Europa's equator may be covered in icy spikes called penitentes, which may be up to 10 meters high.
Yeah, I mean, I guess they're guessing at that because there surely can't be any kind of resolution on a satellite that's been able to pick those up. So that must be like a hypothetical.
Yeah, there's definitely some conjecture, but some amazing conjecture nonetheless. Lots of radiation, Matt, on the surface. Which obviously is a bit tricky. But you know what? One of the things I was reading about was that one positive about the radiation coming from Jupiter is that it will actually clean any probe that's going to go down into the surface. It's going to clean it so much that there will be no chance of contamination.
Yeah, that is quite cool.
We can take that from it.
You know these penitentes that stick up from the even though you've got these 10-meter high spikes. The Europa has got the smoothest surface of any known object in the solar system.
Softer than a McDonald's bun?
Not soft, smooth.
Oh, okay. I meant smooth, but carry on.
Yeah, as smooth as a McDonald's bun. Well, someone told me when I was a kid that the Earth, if you shrank it down to the size of a snooker ball, would be smoother than a snooker ball.
Oh, okay. I can understand that.
Do you think it would be? I don't know. I want someone to confirm that, but Europa.
Yeah, I'm not sure about that.
But Europa definitely would. That's like it's very, very smooth and incredibly circular orbit as well.
But it is getting pulled and pushed just like Enceladus on a massive scale. I mean, imagine the tidal pull from Jupiter, Matt.
It's another moon, isn't it? A bit like Dione is doing it to Enceladus. It's Io that's doing it to Europa, isn't it?
Well, Io, Matt, and I don't know if you know this, is the most volcanic place in our solar system. It's so hot. and there's so much energy coming from the pull and tides
push,
of Jupiter that it's just melting rock all over the place.
I loved this description about where all that energy is coming from. It says that the ultimate source of the energy is Jupiter's rotation, and Io kind of actually sort of taps into that rotational energy, and that gets transferred to Io. And of course, Jupiter's so massive that it's barely making any difference to Jupiter's rotational speed. And then that energy that Io now has is transferred to Europa and Ganymede by these orbital resonances. It's absolutely fascinating, isn't it? I mean, imagine the maths and the cool science behind that. It's so cool.
It's just ridiculous. It's just absolutely ridiculous. I love it.
The crust on the outside of Europa, they reckon, is as hard as granite. So it's
really,
so the ice is as hard as granite. It would be.
So that's not going to be easy to drill down into.
Well, no, particularly if you're saying, particularly if the crust is hundreds of miles deep. I mean,
DeGrasse Tyson said that he reckons it's several kilometres deep.
Several kilometres deep.
Still
drilling
through
drilling through granite. I mean, that you suddenly realise, oh yeah. Now, we were talking about how many tons a minute. It was something like 14 tons a minute, wasn't it, that Enceladus kicked up into the atmosphere?
Yeah.
Well, the Hubble Space Telescope detected water vapour plumes, or they think it did, and they now estimate that the water eruptions coming from, these plumes coming out of Europa are something like 420 tons a minute. So that's 35 times more material than Enceladus.
It's just ridiculous.
Yeah, and not only that, Europa's got a thin atmosphere and an ionosphere. So there's a molecular oxygen atmosphere and an ionosphere on Europa, again revealed by the Hubble Space Telescope.
So it might be hard for us to go and live there, Matt.
I think the radiation kind of puts a downer on it.
Such a bummer radiation, isn't it?
Yeah, it's pretty harsh there. But maybe this would be cool, wouldn't it? Wouldn't it be amazing if you went to Europa and you found a life form on Europa that, because it was always bathed in this massive radiation, it gave us a kind of gene or some kind of method that it used to stop itself from being affected by radiation. Maybe like all new medicines and new science would be unlocked by finding these new life forms on these icy moons.
Oh, this is another thing. People always talk about, why are we spending all this money going to these places? It's not going to help us. We've already proven that that's absolute bullshit. Imagine the science and medicine that we could potentially unlock, Matt.
Yeah, it's just incredible. The only thing we have to do is drill through the 62 miles of granite hard ice.
Yeah, that is a big engineering problem. But Matt, we've got some smart people down on here on Earth. But you know what, Matt? The rich brown kind of gunky stuff on the top of Europa is likely the sea salt, they reckon. That the plumes come up and jet out and then they get discoloured. The vapours get discoloured by the intense magnetic fields and turn them brown.
I heard that they might be clay sort of minerals, clay-like minerals like phyllosilicates.
Fake news.
And that actually might be caused from a collision with an asteroid or a comet. That maybe an asteroid or a comet has delivered a whole package of organic materials to kickstart life on Europa.
Now you're talking.
One thing that Europa might not have that Enceladus has is volcanic hydrothermal vents. So that it may not have them. It could, but if it doesn't, even then, 2016 NASA study showed that you could still have all these rich minerals being produced by different methods through this thing called serpentinization. Yeah,
I like it.
So just because it's not volcanic doesn't necessarily mean that you miss out on these kind of hydrothermal vent bonanza. of life.
There's hope yet without the black smokies.
What are the future missions to Europa?
2012, Jupiter's ice moon explorer, JUICE, was selected by the European Space Agency as a planned mission. And that mission includes 2 flybys of Europa, but is more focused on Ganymede.
Yeah, I'm very excited by JUICE. I think that's an amazing mission. We should probably cover it a little bit more on the
Matt,
podcast or something.
I'm more excited by Clipper. In July 2013, an updated concept for a flyby mission was presented by the Jet Propulsion Laboratory, JPL, and also the Applied Physics Laboratory, APL. So yeah, the aim of the Europa Clipper is to explore Europa in order to investigate its habitability and to aid selecting sites for a future lander. But Matt, check this out. I read that Congress has given way more money than requested, but as a clause has insisted that they include a lander, which was never on the cards for the Clipper mission, which is on one side great because they've got more money and they can put a lander in it, but then it doesn't give them much time to sort out the best landing spot. What do you think of that?
Well, yeah, particularly considering you've got all these massive jagged ice spikes.
Yeah, not good.
Yeah, like you said, that whole idea of the spacecraft maybe contaminating either of these pristine, beautiful, icy worlds is a real problem. I think that's a much bigger problem.
We need to take that seriously. I mean, Congress obviously aren't the scientists in it, and they want to hurry up and be the first to find life on this icy moon. But you can't rush some things, can you, Matt? You've got to figure out where the best place to drill down is.
What of course could have happened already, of course, is that both of these moons have been contaminated via lithopanspermia, i.e. collisions on Earth, like the one we talked about last week, that new crater that they found under the Greenland ice sheet.
That's right.
Maybe that kicked up loads and loads of bacteria and tardigrades and other life form, bunged it up into the upper atmosphere. Then the solar rays and solar wind has blown it across the solar system. Tiny, tiny bits of them have managed to be covered in soot and survive and ended up on Enceladus and Europa and just about eked out their new life on those habitable planets. Maybe.
I think we should make a film, Matt.
Yeah, so they could have already have been infected. Or, even more interestingly, not from Enceladus because it's too young, but maybe Earth was seeded from Europa. Ever thought about that?
Whoa.
Actually, I think that's probably less likely because I think both the moons formed after life on Earth had kind of kicked off, maybe.
They are very young. Actually,
I don't know about Europa.
Oceans, huge oceans of liquid water for billions of years. Certainly Europa. Wow.
Now, we've kind of got to set up a little competition here between Enceladus and Europa and which one's best. I'm a little bit disappointed about how much effort there is to get to Enceladus, and there's obviously a lot more kind of thought about going to Europa. However, Caroline Porco, who we should definitely listen to because she's one of the greatest.
She's great.
Caroline Porco, brilliant genius. This is her quote. She says, "As far as Europa goes, Europa very likely has an ocean under its surface. In that regard, Europa and Enceladus are on equal par. But on Europa, the ocean is at least several kilometres under the surface, and the moon is bathed in an intense radiation field." So I think she probably prefers Enceladus as a kind of place to have a quick check out, see if it's going to work out. What do you reckon?
Well, I think she's right. I mean, my heart goes out to Europa, but Enceladus is there too. I think both are very exciting.
Both are very exciting. They're very, very different. They seem very, very similar on the surface, but very different.
If we did find life on Europa, would they be called Europeans?
Yeah, but maybe that's where Europeans come from.
I think what's very confusing as well, Matt, is that in certainly in Swedish and Danish, Europa means Europe. That's the translation, so it'd be very confusing.
Oh, I'm confused. I'm confused already.
Yeah.
So
Yeah.
presumably Europe is named after Europa anyway.
Well, you would have thought so.
Yeah.
Who knows?
Because it's always good to name a continent after a lover of Zeus.
It is. Well, I'm just going to keep researching this, Matt. I don't care if this podcast is almost over. I'm going to go back. Going to get on YouTube. Going to get online. I'm going to geek out.
I'm going to reform the band Zeus, and
I think you should.
My next album is going to be Zeus, Moons for Lovers.
And I'm going to play Cowbell on the first hit single off of the album, Abiogenesis.
What can people do to support the podcast?
It's really easy. iTunes, interplanetary.org.uk. Everything's on there. Patreon. If you like our show, well, guess what? We haven't got adverts, so we need some help. Can you help donate something? Anything? And you know what? Also, if you like it, why don't you tell a mate? Why don't you ring your mum? Tell her about the Interplanetary podcast. Why don't you buy her for Christmas a way of listening to the Interplanetary podcast? Maybe a nice set of headphones. I mean, Matt, what a stocking filler that is.
That's a very cool stocking filler. I like it. I like the whole vibe of that. So patreon.com/interplanetary. Awesome place to go. Go to iTunes, just be genius, and thanks so much for listening to me and Jamie rabbit on about our favorite about our favorite things. It's been an epic. What always gets me is there's always so much we do this weekly, and there's always so much to write about.
We're learning a lot, aren't we, Matt?
Yeah, we've got some really great guests coming up shortly as well. So tune in next week for more fun and games on the Interplanetary podcast. Putting the ace back into space.
Bye-bye.
Bye-bye.